Okay, so today we're going to kind of wrap up quadratic characteristics by taking a look at some models of quadratics and kind of figuring out what do they mean, and then also make sure that we can fully identify all the characteristics from a quadratic, okay, from a parabola. So let's start with seeing if we can come up with all the terms here, okay? All the characteristics. So remember, we've got two roots. And what are all the names for the roots? Well, they call them roots, they call them zeros, they call them x-intercepts. Okay, roots, zeros, and x-intercepts, those all mean the same thing. We have a vertex, and this one is the y-intercept. Okay, that is the y-intercept. And then remember, this is the axis of symmetry. And the axis of symmetry is really our middle, okay, and it goes through the vertex. Now remember that your domain is real numbers unless it is a word problem, and the range is controlled by the vertex, okay, which means it's controlled by your A. So in this case, this one would be greater than or equal to because it has a minimum. It has a minimum. All right, so let's take a look at an actual application here, okay? So I'm going to pull this to the side. All right, so we've got this freestyle aerial competition. That's where like they ski off this a giant hill and they do flips and stuff in the air. And they modeled her flight with negative 16t squared plus 30t plus 10. Okay, and when we graphed it, it looked like this. All right, so the first question is, how long is Stephanie in the air? Well, what's really going on here? Okay, what's going on? So it's asking us, how long is she in the air? So which one of these is actually time? Well, this is time. Okay, time is here. So if I look at how long she's in the air, right here, this is where she hits the ground. Okay, that's where the ground is. So she would be in the air for a little more than 2 seconds. A little more than 2 seconds. So it says, when will Stephanie reach a height of 15 feet? Well, 15 feet is approximately right here. So she is under 1 second. Okay, under 1 second. And we'll come over here to this graph, to our data over here, and see if we can take this a little bit further. So between 15 feet. So if I look at this, I see that between 10 and 21 is my 15. So she's actually between 0 and 0.5 seconds. So she's under 0.5 seconds from when she leaves the ramp where she actually hits 15 feet the first time, okay? And she has another one on this side where she hits 15 feet, and that is going to be between 1.5 and 2 seconds. So she actually has 2 points where she reaches 15 feet, okay? Now, it says to earn bonus points in the competition, you must reach a height of 20 feet. Will she receive bonus points? Well, yeah, 20 feet is here. She actually hits it twice. So she actually did get those bonus points. Okay. Now, the bigger question is, how far off the ground is the ramp? So is she actually starting on the ground? Or where is she starting? Well, that's where the y-intercept comes in. So right here, the y-intercept, that's a really important part because, first of all, this is negative time. So I can't have negative time. So my graph is really starting right here. That starting point is right about 9. So that's telling me that when she came down off her ramp, so this is the mountain, it comes down and it throws them off, and she goes up in the air, does her flips, and then lands right here would have been 9 feet off the ground. Okay, 9 feet off the ground. So there are some really important context when we're looking at a quadratic problem, including like where's the starting point and where does it hit the ground, or how much higher did I go from where I started. Okay, so let's look at another one. So this one, we've got a golfer. And this golf game can be modeled with negative 4.9 t squared plus 31.3 t, where the height is in meters and after t seconds. So this is meters and this is seconds. Okay, so it says, at what height is the ball hit? Well, the maximum point is up here. So that means my maximum would be 50. Whoops, let's back that up because that's actually going to lead us into two things. So the maximum height is 50. Okay, at what height is the ball hit? So this is asking about the starting point. Where's my starting point? Well, I started at 0. Okay, it's on the ground. That's different than the graph we just saw on the previous page because, I mean, remember, when you play golf, you're going to be on a tee, and that may be like 1/2 inch to 3/4 of an inch out of the ground, but they're going to assume that in this graph it's going to be a 0. How long did it take for the ball to hit the ground? Well, it hit the ground here. Okay, so this is the ground. So it took a little more than 6 seconds, so between 6 and 7 seconds. Now, let's talk about domain and range with this. Is my domain going to be all real numbers? No, the domain is only positive because I only have positive time. So the domain is real numbers, okay? And I could say greater than or equal to 0 because that's my starting point, but I'm actually between 0 and that might be 6.5. So I could actually write this as a compound inequality. I'm between 0 and 6.5. Now, what about my range? Am I going to have all real numbers? Is it going to stop? Do I have anything down here below the ground? Well, it's not going to go clear through the ground and keep going into negative meters. So I'm actually going from 0 to 50 and then back down to 0. So how do I write that? Well, it's going to be real numbers, and I'm going to be between, so again, it's a compound inequality, 0 and 50. Okay, I'm going to be between 0 and 50. So you can see how that does change when we're talking about domain and range on a word problem. Let's go back and talk about the domain and range on this problem. So the domain on this problem, if I wanted to think about where I'm going, I'm starting at 0 and I'm stopping at 2.2, 2.3. We'll go ahead and call that 2.5. Okay, so this is the seconds. That's my domain. The range, well, where am I starting? I'm technically starting at 9, and I'm going up to maybe 24, and I'm coming back down to 0. So I really have to pay attention to the minimum and the maximum. So I'm between 0 and we'll say 24. Get my real numbers in there. And the 9 is in between that range. Okay, so when we move into word problems, the domain and range is related to the context. Okay, so today you're going to be working on analyzing and understanding applications of quadratics. Pay attention to the starting point and the y-intercept. Pay attention to like what's the context. Is the ball starting on the ground? Is the object starting on the ground? Is it starting in the air? Is the diver on a platform above the water? Make sure you're aware of all the context around the word problems and reach out to us if you're struggling.